Math 3, Unit 2, Section 7. Today we're talking about graphing systems of inequalities. So whenever you see systems, that's like basically where two things intersect, where they overlap, okay? Couple things that you need to know when you are graphing is that when you have less than or greater than, it's a dashed line. And if you have the equal sign underneath, it is a solid line, okay? When you are shading, if it says less than, you shade below the graph. And if it says greater than, you shade above. And we'll kind of practice this. It's always a good idea to check a point where the graph shading overlaps, but you cannot choose boundary points, okay? You can't choose any point that's on a boundary line. So that would be like your line that's the graph. Don't check with one of those points. And then after checking points, you can highlight the area that makes a true statement for each of the inequalities. So we're just going to go ahead and get started. So I always kind of like to number them or label them. So if I'm looking back, it's easy to tell which equation is which. You could also use different colors like I talked about. So I'm just going to label that first one as equation 1, and I'm going to do it in a pink color. And so for equation 1, what type of graph is that? It is linear. Very good. And what would be, there's one thing, I don't really like how that one is set up. And so personally, I would rewrite this in the order that makes the most sense to me, which would be y is less than or equal to negative x plus 5. Because whatever's in front of the x is like my slope. Since that negative is with the x, that goes in front, and then the 5's at the end. So what would be my starting point here? Very good. So my starting point would be 0, 5. And can I use my slope on this one? Yes, because it's linear, right? And what's my slope? Good, negative 1 over 1. And the negative doesn't matter which one it goes with, right? It just has to be with either the top or the bottom number. Okay, so we're going to go ahead and graph this. So 0 up 5. Make our point. A lot of times I just go and graph the line and I forget to check if it's solid or dotted. So if you ever do that, you can always go back and double check it again later. But in this case, I know for sure it's going to be a solid line, okay, because it has the equal to sign. Okay, and so using my slope, I'm going to go down 1, right 1, or I'm going to go up 1, left 1. And I like to usually put like a few points on there to make sure my graph is accurate. And then take some sort of straight edge to draw your line. And again, I'm going to mark this as equation 1. The other thing is that this says less than. So looking at your line, something is above and something's below in terms of shading. So what would be below the line? Would it go down or up for the shading? Down. Less than is down. So we're shading down. If you're ever not sure, you could choose a point that's not on the line and check it. If it makes a true statement, you shade on the side of the point. If it makes a false statement, then you shade on the opposite side. Okay, and I'm only going to show you for this one right now because we're going to go back through it. But for instance, if you weren't sure which side to shade, 0, 0 is not on the line, so that would be a point I would choose. And so for the point 0, 0, that's your x value and your y value. 0, I'm plugging in for y, is less than or equal to 0, I'm plugging in for x, plus 5. Is 0 less than or equal to 5? Is that a true statement? Yes, so since it's true, you shade on the side that has the point 0, 0 on. Okay? If you understand what is less than and where to shade, you don't have to do a point at this point. There's another time you're going to have to use a point though. Okay, so equation 2. This one is y is greater than 3x minus 4. And what type of graph will this be? Linear as well. Good. And what is my starting point for this one? 0, -4. Very good. So 0 down 4, 1, 2, 3, 4. Is this line going to be dotted or dashed or solid?
Dotted.
Good. So sometimes I say dotted, sometimes I say dashed, but you guys understand both, right? Yes? Okay. What's my slope? 3/1 is correct. So we're going to go up 1, 2, 3, right 1. Up 1, 2, 3, right 1. And I usually like to go above where the other graph is. And then we said that this one was dashed, and so you just want to make a dashed line. If you forgot and you drew a solid line, just go back and like make it so it looks dashed. Okay, either by erasing or coloring it in darker. All right, and then this one says greater than. So each line is different, but on this line, okay, which way do you think is greater? So it's greater than, we're going to call this side A and this side B. Would we shade on A for greater or B for greater? A. You would shade up. Greater is like your bigger values, so you want to be shading up. Okay? This is greater. Even though it's like on the negative side of the graph, as this goes to infinity, it's going to keep going more positive, where this one's going to go down and be negative. So think about how it expands, and this one will end up going up. And so this is the side that we would shade for greater. Now, do you see where the two graphs overlap?
Yeah.
Okay, so this is where we want to name 2 points. So we're going to choose 2 points that we want to check to make sure that they make true statements for both graphs. Okay? So we can choose any points that we want to. I always try to choose something like on the X or Y axis, because then I have 0 in it and it makes it easier when you have like zeros or ones. And so do you see how 0, 0 is a point that's in both of the shaded areas for both of the graphs? Okay, so I'm going to try 0, 0. Okay, and then another point we could try would be, we could do 0, 1, sure. Okay, 0, 1. So 0, 1 is just right here. So we always have to check 2 points. You're going to do the same thing on your test. You're going to have a question that's just like this on your test. So we start with equation 1, and all we're doing is plugging in the point 0, 0. But didn't I already do that for 1? So I'm just going to give it a check mark because I already have that work there for 0, 0. Okay. Then we're going to plug it in for equation 2. So again, x is 0 and y is 0. So I have 0 is greater than 3 times 0 minus 4. 0 is greater than, 3 times 0 is 0, right? And 0 minus 4 is -4. Is 0 bigger than -4?
Yes.
Yes. So this works out. Both of these were true. Okay? And so 0, 0 is a point. So that's 1 point I can for sure name. Do you guys understand what I'm doing?
What's the right there with the one with the little check mark in the first one?
Oh, it was supposed to mean that it's true. It works. And I just didn't work out the stuff because I plugged in 0, 0 already over here. So I already did it for equation 1, and so it's the same work, so I decided not to do it again. Yes?
So all you do is plug back in the points to the equation, right?
And make sure they make true statements. So now we're going to plug in this point to make sure it makes a true statement for both of our equations again. Okay? So I label these as x and y to make sure I'm plugging in the correct points, correct numbers. Okay, and so for the first equation, equation 1, instead of y, I'm writing 1 is less than or equal to 5 minus 0. So we have 1 is less than or equal to 5. Is that a true statement?
No. Oh, yeah.
1 is less than 5, right? Okay, so we can write true, okay? So we understand what we're doing. Or you can write out the word true, so you knew that's what we were doing. Okay, true statement. Okay, now we go to equation 2. Instead of writing y, I write 1 is greater than 3 times 0 minus 4. 3 times 0 is 0. And what is 0 minus 4? Negative 4. Is 1 greater than negative 4? True. And so both of them are true statements, so it checks out. And so we can go ahead and write another point as 0, 1. Will we all get the same points? No. But everybody should have 2 points that are in this area. And so we proved that it was true for both of those. And so this is the area where our actual solution is. And so we normally highlight it or color that area darker. Okay, are there questions before we move on to the next example?
Wait, so why do we do it?
Because this is where it's true for both graphs. So both graphs overlap here. We thought the answer was here. We checked 2 points to double check that it was true, and it was. And so we just highlight this or make it darker so it stands out. So like on your answers, it would only have this area highlighted. If it was a multiple choice, you would choose where it all overlaps. Okay. Any other questions right now? Okay, let's move on to number 2. So number 2, again, I like to label these and use different colors. So with equation 1, what type of graph will that be? Good. Another line, or I'm just going to write that as linear. And we have y is less than or equal to negative 5. So where do I go to graph that? Negative 5. So 1, 2, 3, 4, 5. And I'm going to go ahead and draw my line. Okay, and that's my equation 1. So now we're going to go to equation 2. And what type of graph is equation 2? Very good. Okay, what will be my vertex or starting point for my quadratic? 4, negative 1. Remember that whatever's with the x in parentheses, always the opposite, because you'd set it equal to 0. And then this is your y value at the end. Okay, so 4 and then negative 1. So write 4. 1, 2, 3, 4, down 1. Now, is your graph going to go up or down? The graph is going to go up. Okay, I'm just going to go ahead and curve up. Normally, if these graphs overlap, you want it to be accurate. Okay, because you want to find the exact points and see what's happening. But in this case, when I curve, well, actually, this one's going to be no solution. What did I forget to do on this one? I just realized. Shade. Which way should I have shaded? Down. Less than is down. So I'm going to go ahead and shade this down. And on this one, let's go ahead and plug in the points. Let's make sure this is accurate. So what point would be a good point for me to plug into this quadratic to make sure it's accurate? 3 would be a great point, because 3 is like 1 to the left, okay? And so if I plug in 3 for x, we get y is greater than 3 minus 4 squared minus 1. 3 minus 4 is negative 1. What is negative 1 squared? 1. Good. And then so we have 1 minus 1, which is 0. So we have y is greater than 0. So I'm going to go, so at 3, it's at 0, which means at 5, it's also at 0. Because remember that quadratics are symmetrical. So once you have 1 point on one side of the quadratic, if you just count to the vertex and count that same amount to the other side, you have your other point. Okay, and so now I'm going to draw my curve. And where do you think greater than is? So when you have quadratic functions and stuff, one of the shading will be inside the curve and one is kind of like on the outsides. Yes? Very good. And this is exactly what I'm talking about, that sometimes I forget if it should be solid or dotted. So since I'm using pen, I'm just going to go back and make this dotted, and you guys can have a candy, both of you. Why is that one dotted? Very good. It doesn't have an equal to sign. Now, where do you think greater than is going to be shaded?
Inside.
Inside. If it had said less than on this graph, then we would have shaded around it. And then there would have been some overlapping. Okay? So this one is just shaded on the inside. So are there any points where these two graphs intersect? No. So first of all, the answer is no solution. And because the answer is no solution, there are no points. You could put none, you could put NA, you can write whatever, but there's not going to be any points where they overlap. Okay? Questions? All right. Here we go. Number 3. Equation 1. What type of graph is that? Very good. Absolute value, which means what is the graph going to look like? Very good. A V shape. So we have y is less than or equal to the absolute value of x minus 2 plus 1. What is my vertex? Very good. 2, 1. Can I use my slope on this?
Yes.
Good. What is my slope? Perfect. So we go to our vertex first. We go right 2, up 1, make our point. And from there, we're going up 1, right 1, and also up 1, left 1. Right. So it goes right and left because it's symmetrical. So we can go up another one on each side, and then I would get my straight edge and draw. Oops, is this supposed to be, I forgot to check again, solid or, oh, it's solid. Okay, good. I'm good then. I just can't draw very well. Okay, so looking at that one, less than. Where am I going to shade? Outside. Okay, so greater than would be inside here and less than is outside. So, and again, I just kind of like lightly shade it so I can kind of see what's going on. Okay, let's go to our second equation now. And the second equation is absolute value again. Very good. And do I want to rewrite this one a little bit?
Yes, you do.
Very good. And so when I rewrite this one, how will I rewrite it?
Negative x.
Okay, y is greater than negative absolute value of x minus 1 plus 5. Very good. What is my vertex? 1, 5 is correct. And we know that we can use our slope, and this time my slope is very good. Okay, so we're going to start with our vertex. We're going to go right 1, up 1, 2, 3, 4, 5. This one is going down. So negative, so we're going to go negative 1, right 1, and left 1.
It's done.
Very good. Thank you for telling me ahead of time. And so we're going to go ahead and make our dotted, our dashed line. Okay, greater than. Where do you think I'm going to shade for greater than on this one? So it's going to be on the,
Inside of the first one.
it's going to be on the outside of the green. Okay? So I'm just going to shade the outside of the green. And do you see where it overlaps?
Yeah.
So it looks to me like there's overlapping on each of these sides. Do you guys agree? Okay. So we're going to choose 2 points. Did you say no? Oh, okay. No. All right. So we're going to choose 2 points. Let's choose one on each side. I'm going to choose something that I know is in like the overlapping section. And so if I go like right here, that's at 1, 2, 3, 4, 5, 6, 7. Negative 7, 0. For 1 point. And then let's choose like this one way over here. And that's at 1, 2, 3, 4, 5, 6, 7, 8, 0. So those are 2 points I think are going to work. So for negative 7, 0, label them as x and y. I'm going to go to equation 1. Here's equation 1. So we have 0 is less than or equal to the absolute value of negative 7 minus 2 plus 1. What is negative 7 minus 2? But then the absolute value of negative 9 is, so 0 is less than or equal to 9 plus 1. Is 0 less than or equal to 10? Is that true or false? True. Okay, or you put yes or whatever. Okay, but that's a true statement. And then now I need to check the same point with the other equation. So equation 2. Okay, and here 0 is greater than negative absolute value of negative 7 minus 1 plus 5. What is negative 7 minus 1? Negative 8. Two negatives add, it stays negative. But the absolute value of negative 8 is 8. But do you see how there's still negative outside? So that's a negative 8 now. Plus 5, and what does that make? Negative 3. Is 0 greater than negative 3? Yeah, so that one is also true. If one of these made a false statement, you picked a bad point and you need to go back and check, or you didn't shade correctly, so you need to go back and check your shading to see if you went the wrong way. So one of the points is negative 7, 0. We check the other point, x, y. Okay, we plug it in, so equation 1. 0 is less than or equal to the absolute value of 8 minus 2 plus 1. 8 minus 2 is 6. The absolute value of 6 is 6, and 6 plus 1 makes 7. Is 0 less than or equal to 7? Yep, that's true. We go to equation 2. 0 is greater than negative absolute value of 8 minus 1 plus 5. 8 minus 1 is 7. Absolute value of 7 is 7, but we have negative 7 plus 5, which makes, and is 0 greater than negative 2? Yeah, so both of those were true, so this point does check out, and so negative 7, 0 and 8, 0 are 2 points that work. Again, you're going to have different answers. Everybody chooses different points, okay? All right, number 4. Say that. Yeah, there's 3 graphs this time. So this time, I guess I'm going to want how many colors? 3. Okay, starting with my first equation. What type of graph is that? Good. It is linear. And we have y is greater than 1. So we're going to go up to 1 on the y-axis. And solid or dashed? Okay, and on this one, greater than, which way will I shade? Up, good. And again, notice that I don't shade it in too dark because really my answer is where all 3 overlap. Oh, and I forgot. We forgot to highlight this one. So everything worked out, so we should have highlighted these areas. So that side over there. And that side there. Okay, back to number 4. Okay, equation 2. What type of graph is that? Very good. Exponential is correct. Okay, and that is y is less than or equal to 3 to the x power. When we are graphing 3 to the x power, this is where we plug in our points. So I'm going to plug in 0 and 1 and maybe 2 for right now. When you plug in 3 to the 0, what do you get? 1. 3 to the first is 3. 3 to the second is 9. So let's go plot these points. So 0 up 1, there is a point. 1, 3. And 3 is at 9. And remember that there's an asymptote. So when I graph this line, it shouldn't ever cross what? The 0, okay? Because this one didn't shift at all. So the exponential function looks like this. And where do you think less than would shade on this one? We'll call this A and this B. B is correct. Good. So we're going to shade down around And right now, can you see where those two are overlapping? So right here in the top right. Okay, so now let's get our third equation. What type of graph is our third equation? Linear? Okay. And when we write this one out, y is greater than or equal to negative 2x minus 1. What is my starting point? Good. 0, negative 1. Can I use my slope here? What is my slope? Good. Negative 2 over 1. So we're going to go 0, negative 1. And then from there, I'm going to go negative 2, right 1. Or I could go positive 2, left 1. And would this one be solid or dotted or dashed? Solid. How do I know it's solid? Very good. It's equal to. And on this one for shading, A or B? A. So this one, this time, because it depends on how your lines are formed, because this one has a negative slope, but so greater than, your positive values are going to be up, and the negative values would be down. So we shade up. So where do all the graphs overlap? Yeah, on this top right area. We're going to go ahead and highlight it right now. We're not going to have time to like check all of our points. But this area right in here is where all three are overlapping. Can you guys pick a couple points you know for sure would be in that area? So I'm like, okay, let's see here. 2 up, 1, 2, 3. Good. 2, 3. What's another one?
3, 2.
Good. 3, 2. Okay. And again, you guys know the process of going through and checking those. But for time's sake, we are not going to check them. Okay, number 5. Last one here. This one just has two equations again. So starting with equation 1, what type of graph will that be? Very good. Absolute value. What is my starting point? 0, negative 2. Good. And that one is specifically my vertex. And can I use my slope? And what is my slope? 1 over 1. So we go 0, negative 2, and then we go up 1, right 1, and up 1, left 1 a few different times. And is this line going to be solid or dotted? Good. Solid is correct. Go ahead and graph this. Okay, which way will I shade? A or B? A or B? B. Good. Okay. Equation 2, what type of graph? Quadratic is correct. Okay, exponential has an x in the exponent. Exponential, x in the exponent. This does not have an x in the exponent. A square term means it's a quadratic. So this equation, y is greater than or equal to 2x squared minus 5. What is my vertex or starting point? 0, negative 5. Okay, so 0 and then negative 1, 2, 3, 4, 5. Okay, is this graph going to end up going up or down? Up. What would be a good value to choose?
1, 0.
We can try 1. I'm going to try 1 and plug it in to see exactly where I'm supposed to go. So y is greater than or equal to 2 times 1 squared minus 5. 1 squared is 1. 2 times 1 is 2. And 2 minus 5 is? Okay. So y, so basically my point is at 1, negative 3. Do you guys agree? Okay. So right 1, down 1, 2, 3 is a point. And then that means we go to the vertex where the vertex is, and then 1 on the other side. Is this line going to be solid or dashed? And it says greater than. Where do I shade for greater than? Inside. Do you see where they overlap? Yes, they overlap right here in this area. And what would be 2 points that are in that area? 0, -3, and 0, -4. Looks good to me. Any questions?